Okay, so hello everyone. Welcome to the final day of the Monsoon Series. And today with us we have Nagamitesh Nagamurali, who is a sophomore at the Cornell University, majoring in mechanical engineering, and he is very passionate about space technology and rocketry. He has worked with rockets throughout his high school, and in high school he worked on autonomously guided and non-guided models of rocket, and is currently pursuing higher power rocketry certifications. In college, he has continued his work with rockets as a part of the Cornell rocketry team and is currently working on integrating their new hybrid rocket engine into the launch vehicle. He has also very recently finished his internship with BAE Systems, which is a leading defense contractor specializing in electrical warfare and avionics technology. Thank you so much for joining us, Nagamitesh. So, can you
Yeah,
just
happy to be here.
firstly tell Yeah. Can you firstly tell us, like, how did you come into rocketry? Because rocketry is something, it's literally rocket science. So, how did you come into rocketry?
Yeah, so for me, the biggest thing that when like I started was I was really interested in like space and kind of like space technology, and I learned a lot about planets and stuff in high school, as you do, and I also love the movie Martian, and so it got me really interested in thinking about like what kind of technologies there is that we need to when we go into space, and I also loved engineering in high school with a lot of robotics, rocketry, so I was like, hey, what if I learn more about space? And then I got really interested in like model rocketry in high school, like you mentioned. And from that, yeah, it kind of just went from there.
Yeah, yeah, sure, you can continue.
Yeah.
Yeah.
That's kind of like how I got
So,
started. And then I kind of realized like the future is kind of in space for us.
the last line which you said is the future is in space, but
Yeah.
a lot of people have this thing that going to outer space is just for interplanetary travel
Mhm.
or something which astronauts have. It doesn't have an impact in their life. So do you believe that space and uh, space technology and rocketry, how does that impact our personal lives, or how is it used for good for the general people and the humanity?
Yeah, so there's a lot of things that came from like space travel. So for example, if you've seen the kind of like Mylar blankets. Mylar was originally like created for space travel. It was a material that they used in like the space station and like a lot of like the old space shuttles. So that's just like a simple example of something that was used for space travel, but now it's very commonly used in a lot of like humanitarian aid, just like a lot of things. Same thing, I think, with like Kevlar. Kevlar was one of another example of something that's kind of like made for space travel, but we use it very commonly nowadays, like satellites. Without satellites, we wouldn't really have internet that much. We wouldn't have GPS. So a lot of the things that we might think are kind of like exotic technologies we do actually use in our day-to-day lives.
Yeah, definitely. Those were some, very crucial innovations that came
Mhm.
out of rocketry. What do you believe are the biggest barriers to get into rocketry? Because, it's literally, again, rocket science. So you started in your high school. What challenges did you face while going into rocketry?
Yeah, so I think for me, one of the biggest challenges was cost. So even for like the model rocket like stuff that we built in high school, often like the kit was maybe like around like $100. You have to buy a motor for like $30, $40. And it does get pretty expensive pretty fast. So for our like whole like let's say like a season of like model rocket building, we often spent like $2,000, $3,000. And that's not really attainable for most people. And we were kind of lucky in the sense that we had a rocket club near my school. Like we had really good mentors who would like teach us about model rocketry, teach us about everything we needed to know. But I also know that's not the norm. Like most people don't have access to those kind of resources. So I think the resource gap is honestly the biggest thing that's kind of hard to get into rocketry with. And other than that, it's also like a lot of the ideas you think of might be applicable for like, the big rockets that are like meters in diameter. But then when you're going down to like inches, like it's really hard to find stuff that fits those criteria. And that's another big challenge.
Building to your previous point which you mentioned is this, you had the access to club, you had access to a rocket, good mentors. What do you believe in rocketry as general are obstacles which not just you, like, others face, and what more can be done to make it, make rocketry more accessible for others to enter and explore?
Absolutely. I think the biggest one is definitely the cost. So having maybe like more companies being willing to sponsor teams that are interested in model rocketry, maybe like a SpaceX grant or something. And I know like right now, like First Robotics is huge all across the world, but rocketry, even though it has the same impact on people, it doesn't really have that level of like engagement, that level of like sponsorship. For example, for like First Robotics, you can get like a grant of like a thousands of dollars if you're a new team starting. We can't really do that for rocketry. Even our competition only has around like I think 1,000 teams in high school, only 100 teams now in like Cornell, like in the Cornell competition that we go to. So something like that where it just I feel like needs to be expanded more, and that's something that's not happening.
Awesome. There's one question which Tamanna has asked in the chat section. She asks, what skills and experiences are most in demand in space industry, and how can I develop these skills?
That's a great question. I think in the space industry, there's honestly demand for all types of skills. So even stuff from like a biologist, like you need to figure out how to grow plants in space. You need to design like ISF, like experiments that need to be happening there. Like for example, physicians, you need a lot of physicians to like monitor the astronauts. So I wouldn't say there's a specific field that's in demand or not in demand. But what I will say is I know a lot of my friends are now majoring in like aerospace engineering, which is starting to become a bigger and bigger field as more companies are being engaged in like space travel and creating more like spacecraft. For example, like Virgin Galactic has their own thing, Blue Origin, SpaceX. So it used to be like you had to work at, for example, like ISRO or you had to work at NASA, but now there's so many more companies that are engaging in like commercial space travel that aerospace engineering might be a good field to kind of learn more into, get more info about space travel. I'm personally pursuing mechanical engineering, and I'm also working with electrical engineering. So I think the other thing that's really in demand is somebody who can combine different fields together. For example, like computer science and like mechanical engineering, electrical engineering. And whenever you combine two fields, that's always more in demand than just doing a single field focus, in my opinion. If you
Yeah,
could find
that's
your
a
niche,
very
of course. Yeah.
Yeah, yeah, that's actually a very interesting point that you do interdisciplinary or multidisciplinary studies, because then you're combining two or more concepts from various different field together. A question in chat is again that for an high schooler applying to MIT or any particular say college, what books or projects should one recommend? So adding firstly, I think you can answer that question, and then I would like to add a second question to that is what factors should one keep in mind while building projects related to mechanics or rocketry or aerospace?
So for the college admission part, I will be honest, there are many, many ways to get into top colleges. And I can't specifically speak on like a specific project that will get you there. But I will say that international projects or like stuff that gets like displayed internationally, for example, like ISF or other international competitions definitely does have an edge up. And that does matter a lot more than let's say more local kind of events, obviously. That is honestly all I can say in terms of that. And it is a very hard process, especially coming from like another country. For me, it was somewhat easier because I'm like in America, but I will say that is a big challenge. And in terms of like what you need to keep in mind for like building these kind of like mechanical engineering projects, building things like that. I would say the hardest part is always like planning and figuring out what constraints and like having proper ideas. For me, a lot of the planning comes from just like I have to think about what I can do and what I can't do. And for example, even if I'm building a catapult, I need to know how far I need to throw, and that's gonna like tell me, okay, I need this material, or if like I'm throwing something heavy, I need that material. So it's always the planning and kind of like figuring out what you need, what you don't need is the most important part in my opinion.
And could you go ahead and what factors should one keep in mind while building a project? So deadlines, because in
Mm,
rocketry and even robotics for that matter in FRC, cost is a very big issue. So how do you
mm.
go on tackling cost and building a project? at your capability, if with a club or maybe even without a club?
Yeah, so first you need to figure out what you have and don't have, of course. So one big resource that I'd say is really helpful is like having a makerspace. A lot of makerspaces, I don't know how popular they are in India, but a lot of makerspaces have like 3D printers, they have laser cutters, they have a lot of stuff that you can use to build your project, and that brings your cost down a lot. Because for example, you pay them maybe like $100 to go use their facilities for like a whole month. And that's going to give you so much more resources than if you're going to buy all of these tools on your own. So finding space like that is really helpful. And in terms of cost, it's honestly figuring out what is the cheapest things you can find. And maybe you could buy a broken microwave for like $10. And then inside the microwave, you have like a motor that you can use for the spinning table. You have like an AC/DC converter. So stuff like that. So you can just buy junk from somewhere and then reuse those parts into your project to make it something really good. That's a great thing that I've kind of tried to learn. Like, even for robotics, we were getting rid of a lot of old parts. I took all the parts, now I'm using them in different projects.
Yeah, that's actually a very cool idea. And can you go and tell more detail on how you are reusing these parts, because that sounds very interesting.
Yeah, so for example, for our old robot, so what happens in for example, I was an FTC, and what happens is we have a lot of like Vex parts, we have some Go Builder parts, we have stuff from different vendors, and my like team, not my team lead, like team mentor was getting rid of a lot of our old Vex parts. So I kind of ended up with like a lot of like one of those like Omni wheels, a lot of things like that. And with those Omni wheels, I made like a little robot. So I had a light seeking robot that I made in like middle school. So I kind of put like the Omni wheels on that, kind of made it do a lot more in terms of like strafing and stuff like that. So in terms of that, like those wheels by themselves probably cost maybe like $100, but then I got them for free from my team. And of course, it doesn't have to be from your team; it can be from a wide variety of sources. So it's stuff like that where that was really nice for me to just have.
Yeah, that's actually a very interesting point which you got to learn. Now, Taknul has a question. He asks, do you see the growth of AI having an effect on Rocket?
I have seen AI play roles. So I forgot what the name of the company was, but there's a cool company making like drone swarms that can automatically detect threats and go neutralize them. That's, I feel, a really good way that AI has been changing kind of the whole landscape of now you can identify threats, analyze them, and execute your thing in like millisecond or like seconds rather than, having a person manually looking at it and stuff like that. And in terms of AI on, let's say, like the work side, like as an employee, AI is still not at the space where you can use it for a lot of defense or like industrial applications. Because when you're going to space, you need zero defects. Like that is like during my internship this summer, that was the biggest thing that always stressed. You need zero defects. Like if you have a single defect, you are putting somebody's life on the line. You are killing somebody. And AI isn't at the space where it can do that. Like there's a lot of hallucination. There's a lot of issues. Like we weren't even allowed to use AI or like ChatGPT at all during my internship. And that's like I think the biggest reason why AI right now is not a big issue, but as it gets better, hallucinations are more like let's say calm down. I feel like AI will start being used to maybe like create like competence, stuff like that. But right now, I don't think AI is at this point where it's going to be taking your jobs kind of thing.
Yeah, that's actually a very interesting point and a very good industry insight on how AI is. Can you also give, what more trends or advancements you see in rocketry or drones, which you are very excited about?
Yeah, I think there's honestly a lot of cool things. And one, sorry, I do have some notes. I'm trying to just like find it. Yeah, and one of the really cool things I've seen is kind of like I was saying, like the drone swarms, the proliferation of really low cost drones. So a lot of like you can find a lot of drones now that are maybe like $100 and you get like a camera on them. They're like FPV drones they can build yourselves. And I feel like that's really cool. Like so for my high school like team, I was 3D printing like drone chassis. So it's like one of those drone chassis now like $2, $3, where if you were kind of like buy commercially, it'd be like 50, $60, right? So I feel like the proliferation of really low cost drones is enabling people to get into that a lot easier. And I know this is kind of like a saddening thing, but it is now being used a lot in like warfare. So the technology is definitely like growing at such an exponential rate that drones are going to be so more like mass produced and so much more common than they are currently. And drones are also being used for good things like transporting like medical aid. There's a company called Zipline, I think in like rural Africa, and what they're doing is they're putting it on like a glider, launching the drone to like drop supplies to where you need it, and that kind of stuff is also really cool.
Yeah, definitely Zipline is doing really interesting
Yeah.
and really impactful in Africa. Now, anything, like more than that, there's uh, a lot of negative effect also, like you mentioned about the warfare or their low proliferation creates more risk. How do you see that, what kind of systems are being placed or what kind of mechanisms are being built to counter that or to, reduce the or mitigate the negative impact of such a low proliferation of drones?
Yeah, so I can speak specifically like what's happening in like war zones. So one of the things that has been used is when you have a drone, you need to control it with like controller. And that usually works on like radio waves, something like maybe microwaves. And the thing with that is you can just put like an EMF shield over your devices and that's gonna stop that from penetrating. So what a lot of like for example in the Russia-Ukraine war, what's happening is like Russia's using like signal jammers to essentially just jam the signal, their drones just drop out of the sky. And of course, Ukraine's doing things to, like combat that. And one thing that kind of does scare me and is not being controlled right now is the use of like autonomous drones. Like what's happening is a lot of countries are now building more autonomy in their drones. So you can have a drone automatically go kill somebody. And removing that emotional like barrier pulling the trigger is really scary because now you can like kill hundreds of thousands of people without pushing a button, which is not good. Like removing that emotional thing. So honestly, there should be more protections in place. Like it's the whole thing with AI. There's not enough protections in place right now, and I feel like there has to be more like laws or changes made to have that happen.
Okay, coming again to what do you find exciting in rocketry?
Mm.
Tamanna has a question which is like, what roles do you believe are the most exciting or in space industry, or what career paths are most interesting?
I think one of the coolest thing is always being like into propulsion. So propulsion, there's obviously like so many different like things that go into it, and that I feel like is the most like rocket sciencey of the rocket science. Like that's the one where you're really doing a lot of math. You're really figuring out like what propulsion, what techniques to use. It's going to be like the most rocket science of rocket science, in my opinion. That one is definitely the coolest. But other roles also are great. Like I'm more into like the structures part of it, like building the like frame of rockets, stuff like that. So yeah, there's honestly a lot of cool roles, and there's not like one thing that I say is like more important than the other. You need everything to make a good rocket.
And again, rocket is a combination of a lot of different things. So what path or like what Taknur asked is roadmap or different career ways by which you can, like, you are learning mechanical engineering and going to the structures part. Someone who is in chemical engineering will be going in the propulsions part for the fuel thing, and maybe third person who is doing the aerodynamics would look into the aerodynamic structure another. So what are these different paths which exist, and what are some majors which one should look at while pursuing them?
So I think honestly, all of engineering majors, for example, like mechanical engineers, aerospace engineers, they're kind of similar in some aspects, but in aerospace, you learn a lot more about the aerodynamics, you learn a lot more about the astrophysics. In mechanical engineering, you learn somewhat a lot of that, but you learn in a more general concept. And I know a lot of my mechanical engineering friends are now like with like propulsion, like they're working and stuff like that. Like you said, chemical engineering, material science, that's a lot of things where you need to figure out like mechanical engineers will give you how much thrust they need, what vectoring they need. But you need chemical, sorry, or material science people to be like, okay, so this is the kind of like chemicals we need to use to make that happen. This is the amount of like oxygen and amount of like fuel we need. And for example, even if you go into like environmental engineering, a lot of those people they need to figure out like what kind of environments to have inside of the spacecraft. They need to figure out what to put inside the spacecraft. Electrical is a huge one, especially with a lot of the new, like the SpaceX, like having motors installed in your um m- like servos or motors installed in your rocket motors to make it like thrust vector. So there's a lot of like electrical engineering that goes in that. And obviously everything now, there's a lot of electronics, there's a lot of power systems, and of course computer science, building these algorithms to control the rockets. Like you definitely need every single major, and you can't. There's not a single major that you're gonna be like, oh, if I do this major, I'm not gonna get into aerospace. Like that's not true. Every single major does have a role here.
Interesting. I will, combine this with the previous thing which you mentioned about interdisciplinary. Can you tell, like, when you have all these people from different backgrounds, how do you collaborate with each other? How do you discuss, like, someone is building a particular part and other person is building a part. How does this happen in stages, or are you working parallelly along with each other? How does that go?
Yeah, so I think overall the most important part is the planning. So in the planning, like we kind of determine like, okay, so if software is working on, let's say, the algorithm for the brake line manipulation system, and hardware is working for the actual hardware for it. How do you kind of combine that? So generally what's happening is that computers, like the computer science people are building their own models, they're like creating algorithms based on those models. And then a lot of times parallelly, like the hardware people are working on the hardware for it. So then in the middle, sometimes like once they both have kind of like a mature product, they're like, okay, so this is what our model says. And hardware's gonna be like, okay, so this is what our like, hardware does. Is that the same? And if it is, then that's perfect. And it should be the same. Because in the planning, you're gonna determine really specific key guidelines, and you have to hit every single one of those guidelines for each team. So there shouldn't really be a space where it's like, okay, hardware wants this, software wants that. That should all be figured out ahead of time so then both teams can work parallelly. So to your question, yeah, a lot of the work happens parallelly, and the way that happens is with a lot of planning. And a lot of like, a lot of things that we do, we have something called PDR, which is like a preliminary design review. So both hardware and software present their PDRs. And that's a great place to be like, okay, so it's kind of going where we want it, the pace is good, stuff like that. And we also have a final design review where it's kind of like, okay, so this is our final product, it works, stuff like that.
That's again a very interesting insight from the industry. Um, Coming to again, because a lot of our viewers are high school or college students, but they are college students who are not a part of some club or say any
Mhm.
particular thing. So they do not have a team, yet they are in a particular major studying. So how can they individually contribute more, or their own individual research to can contribute to rocketry? Do you believe there are virtual communities or some way they can interact with the other or like-minded people?
Yeah, I definitely think there are. And model rocketry is a great way to start that. Modular rocketry, like you get a kit that's not very expensive, I think, and you can, start launching rockets. You can maybe start exploring having like active control of the rockets. That's really cool. I know there's like a subreddit for this kind of like model rocketry. I'm pretty sure there's like a Discord server. I'm not exactly sure what it's called, but I'm sure if you find resources, there's a lot of people willing to help you. That's one thing I've found in rocketry. Like everybody wants to help each other. Like even in like not specifically the Rocket Club, but even just our like mentors, they don't have to help us, but they spend time out of their day. Like one of them's a doctor, but he's really interested in rocketry, so he's helping us, like that kind of thing. There's so many people who are interested in rocketry that everybody wants to help each other. So definitely if you like, find like maybe like subreddits or Discord servers, people would love to help you, like get started on that kind of thing.
Yeah, that's again something really cool. And I think that also addresses an issue that, even those who are outside can somehow start somewhere to be a part of the rocketry.
Yeah.
Can you, coming back to industry, can you tell more of what kind of payload are you building for your corner rocketry?
Yeah, so we have a few different payloads. So I was specifically tasked with building a downward facing camera last semester, so that was my kind of project. I used an FPV kind of like drone camera, pointing it downward, built a whole like battery pack system for it, made sure it could like survive launch and stuff. And then it gave some really cool footage for us from our launch, like seeing everything, and that was really cool. And that was an amazing project. So another one that we have is the brake line manipulation system. So for the parachute, when it comes down, you have like the two kind of lines. So if you can think of like a paraglider, what we're trying to do is use the two parachute lines to essentially guide our rocket where we want it. So rather than having to like go miles and miles away to like go search for it, we'll have it land at like a kind of specific drop zone, which is really nice for us. And another thing that we had is we had another outward facing camera that kind of spun around like gyroscopically. So it gave us a stabilized video of our launch pointing outward, and that was also really cool. So we have a few different payloads. Some other payloads I've seen is I know the MIT rocket team, they put a cow's eyeball inside of the rocket to kind of see the effects of G forces and stuff like that. So yeah, so there's a lot of cool things that you can do with this kind of stuff.
Awesome. That's again interesting. Is there any like you're very near the end of the session? So is there any advice which you would like to give to others or to students in general? Or also there was one question which I missed. Really sorry. There's a question by Tamanna. She asks when a rocket is launched and unexpected issue arises, is it the primarily the AI systems that address and resolve these problems, or is it the human intervention still critical, still crucial in managing such situations?
I would say like generally there's not really AI built into a lot of these machines right now. A lot of it's just kind of like hardware or software that corrects itself. So for example, even if there is a failure, oftentimes the software is built in such a way that there's a lot of like setbacks, fallbacks in place. That's like if this happens, do this kind of thing. Most scenarios are kind of thought of, especially once you get into really far space where you have always like a time latency, and that time latency is all like minutes or like hours. And once you get into that, you need the software to be perfect in order to like address these. And a lot of the spacecraft that are in space right now, they don't really have AI. Like this was before machine learning, before LLMs were kind of created. So honestly, sometimes just some good old-fashioned computer science can take you a lot farther than like artificial intelligence in like some places, I guess, because it does require a lot of processing power, but like just like hard-coded logic doesn't really need that.
Uh, this brings me to a question that how do you define, like, say, how does your team, like, let's, you can't define for the
Mhm.
world, but how does your team define, like, this is AI and this is pure computer science? Because a lot of algorithms also, such as KNN clustering and others, which have been existing since a long time before, they are also
Mhm.
called as AI, right? At the same time, even most cutting edge technologies like deep learning or CNN, where we see this issue of hallucination arising, that is also AI. So where do you draw this line that this is AI and this is not AI? Do you have such line?
Honestly, Honestly, I'm not really sure. I am personally not very into computer science, so I don't know where that line is drawn, but I'm sure that there is a line, and oftentimes it's just like, does it hallucinate or not? If it doesn't hallucinate, it's something that can be used very reliably or has been tried and tested. And I feel like that's kind of the differentiation between like what's being used for early aerospace and what's not. A lot of stuff using now, like you said, doesn't have hallucination, which is awesome, and that's kind of what we need. A lot of hallucination stuff is not really mature enough to put in like aerospace currently, I think.
Okay, thank you so much for your time.
Of
Our
course.
session is officially done. There are some other questions in the chat, and Mitishu wants to ask a particular question. I unmuting, so if that's fine with you, can we go with
Yeah,
that?
that works. Yeah, of course. No, I have
Okay,
time.
sure.
I'm all good.
Sure, thanks. So there's a question by Rachel who asked, "Have you worked on big space projects before?"
So I think the biggest project I worked on is like my Cornell rocketry. So we launch at 10,000 feet. And it does get pretty high. And our rocket is 15 feet tall and like 6 inches diameter. So it's a pretty big rocket and has a lot of like stuff going into it. So I think that's like the kind of biggest project I've worked on. I haven't really worked on anything that you might think of like in terms of like SpaceX or like going actually into space. So that's my goal or like kind of like future dream, I guess.
Okay, and another question is like, what works are you doing regarding rocket? I think this was answered with the structure thing, but if you want to add another line on it.
Yeah, so right now a lot of the work I'm doing is so we have a hybrid motor. So last year we were using a solid motor, which is essentially like kind of what's on the end of a matchstick. It's kind of like you spark it, it ignites, so your rocket goes boom. And right now what we're doing is we're having the liquid oxidizer, so it's kind of like a match without the oxygen and the chemical. And what's happening is we have to now figure out like how to put all those like tanks, all the like valves, all the piping, all of that stuff. And that's kind of what I've been working on. So I've been working on how to like put the tanks in there, how to put the motor, how to attach it properly, all the stress calculation, stuff like that. So that's kind of what I've been working on right now.
That was a very detailed answer, and I hope that thanks. That answers her. This question by Mitushi, I will just ask you that. She asks, that she is working on a project which is revolutionizing education with AI technology, and they are building an app that helps the students that regulates a range of wearable assistive device, and this is for hardware for autistic kids. is it possible to get feedback on that project? And is
Yeah,
there a way she can reach out to you or get help or something like that?
yeah. If you have my email, you can just like put in the chat or something, and like feel free to reach out
Okay.
anytime. Or I can put it in the chat, honestly.
Yeah,
Um,
sure.
yeah. Feel free to reach out like anytime, and I can definitely do my best. And I'm not gonna say that I'm like an expert in this kind of stuff, but I can definitely like, give my 2 cents based on my prior experiences. Absolutely.
Sure. And lastly, Tamanna has a question that do you think humans will ever become multiplanetary species? That's our last question.
Eventually, I think eventually, I think a lot of the stuff that's happening right now, and there is a lot of push to get on Mars. So I think in a good amount of time, maybe even like in our lifetimes, I feel like we will be multi-planetary. Do I think that all like 7 billion of us are going to be on another planet? Probably not. But I think a select few definitely will in our lifetime.
That's awesome. Thank you again so much.
Awesome.
And
Yeah,
yeah,
thank you. It
for
was great
others, we
talking with
are
you.
having yeah. For others, we are having a meet like another session in 45 minutes. So please do join for that.